Good day, I am Chanel Maybe Montiel and together with my pair, King Cuevas, we are the Group 12 and today we are going to present to you the pH and pOH. So these are the learning objectives. Number 1, explain the characterizations of aqueous solutions of acidic, basic, or neutral. Number 2, express hydronium and hydroxide ion concentrations on the pH and pOH scales. And lastly, perform calculations relating pH and pOH. So what is pH? It is known as the power of hydrogen. It measures the concentration of hydronium ions in a solution. It also measures acidity and can be measured through a pH meter. So the solution of pH is equals to negative logarithm multiplied by concentration of hydronium. So this is the pH scale. So the 0 to 6 is the acidic, meanwhile 7 is the neutral, and 8 to 14 is the alkaline or basic. Next is the pOH. It is known as the power of hydroxide ion. It measures the concentration of hydroxide ions or OH negative in a solution. It measures the basicity and its formula is pOH equals to negative logarithm multiplied by the concentration of hydroxide ion. In water and any solution with water, there are always two special particles, which are the hydronium ions and hydroxide ions. These two are connected, therefore having inversely proportional relationships, meaning if one increases, the other decreases. The inversely proportional relationship is determined by the ion product of water, or Kw, as they balance each other. Whether a solution is acidic, basic, or neutral depends on which ion is more common. For example, if makaingon ta nga neutral ang isa ka solution if equal ang amount sa hydronium o hydroxide. Example ani kay ang pure water. Next, makaingon pud ta nga ang isa ka solution kay acidic if naay mas daghan ang hydronium ion kaysa sa hydroxide. Ang example ani kay mga lemon juice. And finally, makaingon ta ang isa ka solution kay basic if mas less ang hydronium kaysa sa hydroxide. Ang example ani kay ang soap water. The relation between these two ion concentration is inversely proportional. Mao kung giingon ganina, expressed as Kw expression. So, Kw is equals to hydronium multiplied by hydroxide. So, negative logarithm Kw is equals to negative logarithm hydronium multiplied by hydroxide is equals to negative logarithm multiplied by hydronium plus negative logarithm multiplied by hydroxide. So this results to pKw equals pH plus pOH. At 25 degrees Celsius, the value of Kw is 1.0 multiplied by 10 raised to negative 14, and so 14 is equals to pH plus pOH. The pH and pOH of a neutral solution at this temperature are therefore pH is equals to negative logarithm multiplied by hydronium is equals to negative logarithm multiplied by 1 times 10 raised to negative 7 is equals to 7. Next is the pOH. pOH is equals to negative logarithm multiplied by hydroxide is equals to negative logarithm multiplied by 1 times 10 raised to negative 7, which results to 7. So if we add the pH which is equals to 7 and the pOH which also equals to 7, we get 14. So these are the summary of relations for acidic, basic, and neutral solutions. So acidic, there are more hydronium ions.
This is how science interact using the pH and pOH concept. Normal rainwater has a pH between 5 and 6 due to the presence of dissolved CO2 which forms carbonic acid. This ginapashow diri ang Mo equations nga ga-show kung unsa sila ga react to each other. H sub 2O times I plus CO2 times G is equals to transformed to H2CO3 times AQ. Acid rain is rainwater that has a pH of less than 5 due to the variety of non-metal oxide, including CO2, SO2, SO3, NO, and NO2, being dissolved in the water and reacting with it to form not only carbonic acid but sulfuric acid and nitric acid. The formation of subsequent ionization of sulfuric acid are shown here by Chanel. pH and pOH are important because they show how acidic or basic a solution is. In biological systems, they help maintain proper body functions such as keeping blood and enzyme activity stable. In industries, they ensure the quality and safety of products like medicines and food. In the environment, they help monitor water and soil health, supporting plant growth and aquatic life. So mag-solve ta, try na to. Calculation of pH from H3O+. What is the pH of stomach acid, a solution of HCl with a hydronium ion concentration of 1.2 times 10 minus 3 m? So this is how it's solved. The pH of a solution is calculated using the formula pH equals to negative log H30 plus, where H30 plus is the concentration of hydronium ions. In this case, the hydronium ion concentration is 1.2 times 10 to the power of negative 3 moles per liter. Substituting that into the formula gives pH is equals to negative log times 1.2 times 10 to the power of negative 3. To solve this, we separate it into two parts. Log times 1 times 2 times 10 to the power of negative 3 equals log times 1.2 plus log times plus log 10 to the power of negative 3 equals 0.07918 minus 3 equals negative 2.92082. When we take the negative of that value, we get a pH of about 2.92. Next, to find the pOH, we use the relationship of pH plus pOH equals 14. So pOH 14 ug minus tong 2.92, which is nakuha na to ganina gikan sa pH, it gives us 11.08. Therefore, the pH of the stomach acid is approximately 2.92, which means it is strongly acidic and its pOH is about 11.08. Now let's solve another problem, which is calculate the hydronium ion concentration of blood, the pH of which is 7.3 or slightly alkaline. So here's the explanation. The hydronium ion concentration of a solution can be found using the formula of H sub 3O plus is equals to 10 to the power of negative pH, which comes from rearranging the equation pH is equals to negative log H sub 3O plus. During a problem, the pH of blood is given as 7.3, which means it's slightly basic. To find the hydronium ion concentration, substitutes the pH value into the formula. H sub 3O plus is equals to 10 to the power of negative 7 times 3, which when you calculate this, you get approximately 5.0 times 10 to the power of negative 8 moles per liter. That's the hydronium ion concentration. And this means that hydronium ion concentration in blood is very low, confirming that blood is slightly alkaline.